Okay, so what we're going to do today is we are going to work on modeling linear relationships. So a linear relationship is a relationship that has a straight line graph. So anything that's a linear means a straight line. So again, a linear relationship is a relationship that has a straight line graph. So we are expecting to see a straight line. So we're going to just dive in here and get started. So logging on. Lenore has just purchased a tablet computer and she is considering purchasing an internet access plan so that she can connect to the internet wirelessly from virtually anywhere in the world. One company offers an internet access plan so that when a person connects to the company's wireless network, the person is charged a fixed access fee for connecting, plus an amount for the number of minutes connected based on a constant rate in dollars per minute. So what's important here is that we have a usage rate for dollars per minute, because that's telling us the rate in the type of rate that we're going to be dealing with. So Lenore is considering the company's plan, but the company's advertisement does not state how much the fixed access fee for connecting is, nor does it state the usage rate. However, the company's website says that a 10-minute session costs 40 cents. So we know that 10 minutes costs 40 cents, and a 20-minute session costs 70 cents, and a 30-minute session costs $1. Lenore decides to use these pieces of information to determine both the fixed access fee for connecting and the usage rate. Lenore makes a table of this information and a graph where the number of minutes is represented by the horizontal axis and the total session cost is represented by the vertical axis. Plot the 3 given points on the graph. These 3 points appear to lie in a line. What information about the access plan suggests that the correct model is indeed a linear relationship? Okay, so lots of words there. First thing we need to do is plot these 3 points. So my x-axis is the number of minutes. And my y-axis is the total session cost. Which one of these is the independent variable?
The number of minutes.
Great, the number of minutes. And then which one is the dependent variable?
The cost per session.
The cost per session. And our independent variable is always represented with what axis?
X.
X. Great. So then on our chart here, we know that this is our X and this is our Y. Okay, so the first information we have is 10 and 40 cents. So here's 10, here's 0.5, so 40 cents would be a little bit below that. And then I have 20 and 70 cents. So 20 and then 70 cents. And then I have 30 and $1. I think my 70 cents is a little bit too high. Okay, we have something that looks like this. Does everyone have that so far? Okay, so what information about the access plan suggests that the correct model is indeed a linear relationship? What about this so far makes us think that this is a linear relationship?
So far, it's a straight line.
Okay, it appears to be a straight line. What else? So what about this? in the past, we didn't necessarily look at things as linear or not, but we used a different vocabulary to describe this. And we would say in course 2 that there was a constant what? Anyone?
Pattern?
Okay, a constant pattern, yes, a constant rate of change. So does it appear to be growing at the same rate?
Yes.
Okay, so if we can identify that, if stuff grows at the same rate, then that would also produce a linear relationship. So now we look at question 2. So we're still going to use this graph, okay? And we're looking at question 2. It says the rate of change describes how the total cost changes with respect to time. When the number of minutes increases by 10, so when it went from 10 to 20, or from 20 to 30, how much does the charge increase? So if this is increasing by 10, what is the increase over here? Go ahead, just one of you come off mute so I don't.
30 cents.
Okay, so 0.30. And then to go from here to here, what was that jump? 30 cents. Thank you. Okay, so the charge increases 30 cents for every what?
For every 10 minutes.
For every 10 minutes. Great. Another way to say this would be the charge per 10 minutes of use. So use the information to determine the increase in cost based on only 1 minute of additional usage. In other words, find the usage charge per minute. So let's think about this. We're looking at the usage charge per minute. So if 10 minutes is 30 cents, how much would 1 minute be? How could we solve that? What should we set up?
Proportion?
A proportion. Woo! Yes. So a proportion, which means that if I have 10 minutes, and that's going to cost me 40 cents, I'm going to set that equal to 1 minute. And then this is my, what am I trying to figure out? I'm trying to figure out how much 1 minute is costing me. So when we do a proportion, we say, how did I get my 10 minutes to become 1 minute?
You divided
By
10.
divide by 10, which means down here, I'm going to do a divide by 10. So what is this rate going to be per minute? So if I have 40 cents divided by 10, how much is that going to be?
4 cents.
Okay. So then, what is the charge per minute of use? So the charge per minute, whoops. The charge per minute is 4 cents. Okay. So now the company's pricing plan states that the usage rate is constant for any number of minutes connected to the internet. In other words, the increase in cost for 10 more minutes of use, the value that you calculated in exercise 2, is the same whether you increase from 20 to 30 minutes or 30 to 40 minutes. So what was that rate again? How much is the increase per 10 minutes?
30 cents.
Okay, so increase per 10 minutes is 30 cents. Okay. Using this information, determine the total cost for 40 minutes, 50 minutes, and 60 minutes of use. Record those values in the table and plot the corresponding points on the graph. So, if this is what we're seeing, how much should 40 minutes cost me?
$1.30.
Okay, and then how much should 50?
$1.60.
Okay, and then 60?
$1.90.
Okay, and then we need to plot those over here. So at 40, I have 130. And then at 50, I have 160. And then at 60, I have 190. So I have something that looks like this. How are we doing so far? Good? Okay, so now it says that using the table and the graph in exercise 1, compute the hypothetical cost for 0 minutes of use. What does that value represent in the context of the values that Lenore is trying to figure out? So how would I figure out what the 0 is?
Subtract
Okay, and what am I going to subtract by?
30 cents.
Okay, so because I'm going the other way, this is going to be a minus 30, right? And then what am I going to be left with?
10 cents.
Okay. So I'm left with 10 cents. What is the 10 cents representing?
The fixed fee.
Right, the fixed fee. So the amount that Lenore has to pay no matter what. Like for just turning on the computer, there's a fixed access fee. So the 10 cents is representing the fixed access fee. So we need to write that down. The fixed access fee is 10 cents. Okay, now let's look at plotting the 0 on the graph. So if I'm at 0, where do I need to put my point? 0 minutes is costing me how much?
0.10.
Okay. So that's like 0.1 there. And then it says to draw a line through the points representing 0 to 60 minutes of use under the company's plan. So let's go ahead and draw our line. So this is where you need your straight edge. So everyone should have out a straight edge. I'm going to turn this because I can't draw a line. Also, because this wasn't like super precise, it might be off a little bit, and that'll be okay. Like, we can move our 1 point. That one's off a little bit, so I'm going to scoot it up. Okay, so I have something that looks like this. Now, here are the things I want you to remember is that anytime we graph a line, it needs to be an actual line. That means you absolutely have to graph it with a straight edge. If you try to connect your dots by hand without a straight edge, that's like a kindergarten thing, okay? We're not doing connect the dots, we're graphing linear equations. So you have to use a straight edge. I cannot emphasize that enough, okay? So please make sure of that. So right now it's looking like this. And what we're seeing here is the rate of change. And the rate of change in context to the problem is what? The rate of change in the context of this problem is what? So if we go back to the beginning that we underlined this important thing here, that the usage rate is in dollars per minute. So when we're looking at this down here, what we're seeing is that the rate of change is the usage rate. The rate of change is the usage rate in dollars per minute. Questions so far? Okay, so now using X for the number of minutes and Y for the total cost in dollars, so we got to write that down because that's important. So X equals number of minutes, Y equals total cost. Write a function to model the linear relationship, minutes of use and total cost. Okay. So Y represents my total. So normally when we write out an equation, we have something that's like total equals something, right? The rest of the equation. So if my total is Y, I would have Y equals. Now in course 2, you wrote equations like this. What do I do with my constant? Who can tell me? What do I do with my constant? Okay, I'm going to pause a moment. So let's go back. Normally my total is equal to, this would be like my rate plus my fixed fee. Okay, and my fixed fee is always represented by my constant because that's not going to change. My rate is whatever per whatever. Okay, so the rate that something's happening. And then my total. So if y is my total, we have that. What is the rate of this plan? How much is Lenore getting charged per minute?
4 cents.
0.404.
Okay, so 0.04x, because x is my number of minutes, plus my fixed fee. What is the fixed fee going to be?
10 cents.
10 cents. So this represents the relationship between minutes of use and total cost. This is how you figure out how much you're going to get charged and then the total amount that it's equal to. And then what we just wrote is a linear equation, which you guys have written in the past as well.